5.4 conservation of momentum in 2 dimensions. Now we discussed conservation of momentum in 1 dimension. Now we have an X and Y component. We want to see how do we do these questions. Now here is a 38 kilogram child standing on a 43 kilogram raft that is drifting with velocity of 1.1 meter per second north. As you see here, relative to the water, the child then walked on the raft with a net velocity of 0.71. After the interaction, the child velocity is this. Before the interaction, both of these two momentum, both child and the raft moving together with the velocity of 1.1. Relative to the water, fluid friction between the raft and water is negligible. Determine the resulting velocity of the raft relative to the water. Okay, so knowing that before the we have a P of system. This system consists on a child and M1 plus M2 multiplied by V. They both moving with the same velocity with the raft, right? After that, PS prime is gonna be P of child plus P of raft. Okay. So I just put a prime means the after interaction that is happening. We just knowing that the momentum is conserved, just equal these two together. You rearrange it for, let's just put that. So we say P of S, which is the whole things here, equal to, so before is PC prime plus PR prime, the raft after the interact. So PR prime is equal to P of the system, P of S, minus P of child, right? So P of system minus P of the child after interaction. Now, as you see in this picture, you will see that P of S, which is the child and raft, is moving north. And then, of course, the child is moving in east. But since I want to minus these two, they are vectors, right? So it's going to be P of S plus negative P of C prime. So first I need to find the, so this is the P of C, right? I need to find negative PC prime. Negative PC prime means you just put a vector opposite to that, it's like that. And then I take this is negative PC prime. I put it successively after this vector. So then I have a vector addition between the P of S and PC prime, right? So, and from here to here will be the resultant. You can use a Pythagorean theorem to do that. Now, first, P of S of the system, look at that. S of the child and raft together, multiply by V of S, give you 89. And then when you do this vector things, we use the Pythagorean theorem to find the hypotenuse, PS prime, PC prime. So we find that using the Pythagorean theorem because this is the 27, right? So M of the child multiplied by velocity of the child, we have the PC prime, right? To be 27, and that one PS is 89. Using the Pythagorean theorem, we can find the PR prime of a raft. If you want to find the theta, just going back here, opposite over tangent is opposite over hypotenuse. Opposite is 27 over 89. So tan inverse of 27 over 89 give you the theta 17. And as you see in the picture, it's gonna be north, 17 west, or 17 west of north. That is the solution. Okay, let me just erase that. So let's just do another question. In a game of the marble, collision occur between the two marble of equal mass. One marble initially at rest. So this is at rest. The marble require velocity of 1.1 meters second at the angle of the theta is equal 40. So what happened? The marble after collision will get the velocity of 1.1. The angle is given as well. So the angle it's gaining is 40. Original direction of the motion, which has a speed of from the original direction of the motion of the other marble, which has the speed of 1.36. After the collision, what is the initial speed of the moving marble? Okay, after collision, we will have the speed of that, which is 1.36. So this is the situation. This is coming, this is at rest, so it hit that. So this go with angle and this one go with an angle. You do not know the angle here. So what you do in this situation, you need to find the x and y component of each velocity. Here is we have theta, the x component is adjacent is cosine 1.1 cosine 40. For y component, opposite is the opposite is sine, so 1.1 sine of 40. So we have an x and y component of that. The same thing we do x and y component of this one. We do not have angle, that we just put it as a phi. So opposite will be the sine, and adjacent, which is x component, is going to be cosine. Make sure your y component is negative because it's down. Conservation of the momentum, you need to write in x and y dimension, since m1v1 plus m2v2 equal to m1v1 prime plus m2v2 prime. So this velocity of the second marble was 0, so you don't have it. Simply, this is for x and y component. So let's just do the y component. For y component of the first marble, it's just moving horizontally. So before collision, it's just move horizontally. No y component. You got the marble one velocity in y direction and second marble in y direction. So you add them up. You have a theta here, which is 40. So you just rearrange for sine phi. You do it, calculate that, get the sine inverse of whatever number you got here. Phi will be 31.2. So the angle that the first marble will be deflected is 31.3. Now you use the x component. So again, we have this same thing for x and y component. Now we're doing that for x component. For x component of that, v1x, of course, we have a v1x prime, we got it, and v2x prime, we got it. We have a phi and theta angle, so we put it there. And this is the v1x, the initial velocity of the marble. So for the practice, do question number 2, 3, 4, and 5 here.